On April 14, 2018, two sinister black jets took off from Udeid Air Base in Qatar. The huge B-1B Lancer bombers, nicknamed Bones, were distinguished by the sinuous profile of their fuselage, designed in the 1970s to reduce observability on radar. However, the B-1's stealth characteristics rapidly proved obsolescent due to advancements in radar technology. The four-engine jets streaked towards the Syrian capital of Damascus, over 1,000 miles northwest, dispatched by Washington to punish the Syrian government for an apparent chemical weapon attack on a rebel-held community on April 4th. However, Syrian airspace is protected by an extensive integrated air defense network of radars and surface-to-air missile batteries. Even with their modestly reduced radar cross-section and jamming support, the Bones were at risk of being detected if they got too close. So the bomber's four-person crews instead used a different ploy, likely around 200 miles away from their target. The B-1s released 19 AGM-158 joint air-to-surface standoff missiles, JASSM, from their bomb bays. As the weapons plummeted to the earth, their 8-foot-wide wings flipped out and turbojet engines sputtered to life. The 4-meter-long missiles leveled off a few dozen meters above the ground and streaked towards their target at roughly the speed of a typical jetliner, following a flight path programmed to loop around elevated terrain and enemy radars, while using a jam-resistant GPS and an inertial navigation system to avoid straying off course. Advanced Project. After the AGM-157 TSSAM project was canceled in 1995, the JASSM project started. The TSSAM was intended to be a high-precision stealthy missile that could be used at close ranges, but poor project management led to rising costs. The military quickly announced a follow-up project with similar objectives because such weapons were still needed. In 1996, Lockheed Martin and McDonnell Douglas received initial contracts for two competing designs. The two weapons were given the designations AGM-158A and AGM-159A for their missiles. In 1998, a contract for further development was awarded for Lockheed Martin's AGM-158A. A turbojet from Teledyne CAE J402 powers the AGM-158A. To reduce size, the wings are folded before launch. The wings automatically deploy upon launch. A single vertical tail exists. With updates from the Global Positioning System, inertial navigation provides guidance. Terminal homing and target recognition are provided by an imaging infrared seeker. Improved bomb damage assessment is made possible by a data link that allows the missile to transmit its location and status while in flight. A WDU-42/B 450 kilograms, 1,000 pounds penetrator serves as the warhead. There are a wide variety of aircraft that can carry the JASSM, the F-15E, F-16, F/A-18, F-35, B-1B, B-2, the B-52, and all of them are designed to carry the weapon. To extend the AGM-158A's range, the Center for Strategic and Budgetary Assessments, CSBA, has proposed making the weapon's warhead lighter. As a result, it would be less expensive than the AGM-158B JASSM ER variant, be available in greater numbers, and be able to be fired from a greater distance away from air defenses of the enemy. Development. The missile's powered flight tests began in 1999. The JASSM began production in December 2001 after these were a success. In 2002, operational testing and evaluation of the weapon began. Two missiles failed tests late that year, putting the project on hold for 3 months before it was finished in April 2003. Two more launches were unsuccessful, this time due to issues with the launcher and engine. The Pentagon approved a $68 million program to recertify the JASSM and increase its reliability in July 2007. The decision to continue the program was put off until the spring of 2008. Lockheed tightened its manufacturing procedures and agreed to repair the missiles at its own expense. David Van Buren, Assistant Secretary of the Air Force for Acquisition, stated on August 27, 2009, that the JASSM would not be produced while additional tests were being conducted. However, subsequent tests in 2009 were more successful, with 15 out of 16 rounds exceeding the 75 benchmark set for the test. As a result, JASSM could begin operating. Up to 4,900 AGM-158 missiles are planned for acquisition by the United States Air Force. In the meantime, the United States Navy abandoned its initial plan to acquire 453 AGM-158 missiles in favor of keeping the dependable AGM-84-ER. Upgraded version. The JASSM Extended Range, JASSM-ER, which was given the designation AGM-158B in 2002, was developed as a result of the U.S. Air Force conducting research into a variety of ways to enhance the AGM-158. On May 18, 2006, a missile was launched from a U.S. Air Force B-1 bomber at the White Sands Missile Range in New Mexico for the JASSM-ER's first flight test. The B-1 is the JASSM-ER's initial platform. The F-35 will be able to carry both missiles externally, which would compromise the aircraft's stealth features. Despite the fact that both the original JASSM and the JASSM-ER are several inches too long to be carried in the internal weapons bay of the F-35 Lightning II. The Long-Range Anti-Ship Missile, which is a stealthy JASSM-ER with a new seeker, is based on the JASSM-ER as well, because both missiles utilize the same airframe. The Air Force conducted a captive carry test of LRASM using the B-1 Lancer to ensure that the bomber can carry it. Lockheed Martin began research in March 2016 on an improved wing design with the goal of increasing range even further. The company was given a contract to create an extreme-range AGM-158 variant in September 2018. A 910 kilograms, 2,000 pounds, warhead would be fired from the weapon, which would have a range of 1,900 kilometers, 1,200 miles, and weigh approximately 2,300 kilograms, 5,000 pounds, 1,000 nmi. Rapid Dragon, a multiple AGM-158 launcher module that would be dropped by C-130 or C-17 cargo planes as a low-cost method of rapidly providing a surge of mass-fired JASSMs using unmodified airlift assets, was developed and tested in 2020 and 2021 by Lockheed and the Air Force Research Laboratory. First operation. During the Syrian civil war, the JASSM was first used in missile strikes against Syria on April 14, 2018, as part of their strikes against 3 alleged targets for the Syrian government's chemical weapons program. 2 B-1 Lancers fired a total of 19 JASSMs. The strike resulted in the destruction of the Barza Research Center, which was hit by all 19 JASSM missiles. 2 missiles that did not explode, according to Russian state media, were discovered by the Syrian Arab Army and given to Russia on April 18 for research. However, this claim has not been supported by any evidence. Initial reports said that JASSM-ER missiles were used, but it turned out that baseline JASSM models were used. A number of AGM-158B missiles were used to completely level the compound where the Barisha raid to capture ended on October 27, 2019. Marking the second time the missile has been used in combat.